Hello, welcome to another Safer Sim webinar. Today we have Andrew McFadden from the University of Wisconsin at Madison. I'm going to hand the floor to Andrew to introduce his project and his team.
Hey, everybody. Like Dawn mentioned, my name is Andrew McFadden. I'm gonna swap. Hopefully, that didn't seem to work. There we go. Can you guys see that okay? Okay. So my name is Andrew McFadden. This is a collaborative joint venture between the city of Racine, the University of Wisconsin, Madison, of course, part of the UTC Safer Sim. And I will be presenting this research, but there's another talk that was scheduled before mine that will run after mine, um, from Dr. Pei Li, talking about a lot of the similar material, but related to automated vehicle interactions with pedestrians. So some of our material overlaps because we use the same methods, but kind of the end result and outcome measures that we talked about will be a little bit different. So with that, I'll jump in. So Dr. Paley, Andrea, Andy Bill, and Dr. David Noyce kind of make up the team for this project. The real motivation behind this project was that rider and driver slash operator trust in AVs is critical to the adoption of the technology. We know that for all new technologies, and AVs are no exception. We have done some recent studies on public perceptions, and that kind of motivated to some degree kind of what we want to understand, mainly on the rider side for AVs. We know that numerous studies have explored that rider trust. Typically, they kind of do some state of preference surveys before and after an AV experience. When I say AVs, I'm going to be referring to automated vehicles that spans the kind of SAE levels 0 through 5 mainly. But we'll primarily be talking about one particular automated vehicle that we use for all of our testing in this experience. But unfortunately, a few of those AV kind of before and after studies have used repeated measures, and so that would be kind of testing for that stationarity before and with some of those perceptions, and then as well as after. And so we want to add to that as well as understand how riders perceive operator ability in control of the AV. So that's kind of this kind of crossover element between the rider and the operator, knowing that there is, for the foreseeable future, for a lot of these tests, there will be an operator in the driver's seat or operating the vehicle, ready to take over in case of a disengagement is needed. So, and the third item is that most experiments on this, Society of Automotive Engineers, AV, are typically looking at level 3 plus using simulators or closed tracks. So in general, what we're seeing is that those public road tests have primarily been reserved for the ADAS systems, the level 1 and 2 AVs that that are definitely interesting insofar as kind of understanding that driver perception of lane keeping or other ADAS systems, but might not have been applied as extensively to these level 3 plus, the more highly automated vehicles. And so our objectives are twofold. One, to understand how riders perceive the AV and the AV driver's abilities, and potentially differences between different operators. And then how do drivers' manual disengagements differ from each other and change with experience over time? And so I will be saying AV driver. In our particular setup, there are two operators. One is behind the wheel. We refer to them as the driver. They can take over operations in case of an imminent collision or the vehicle is not continuing through the intersection or other conflict. And it feels like it won't get through for various reasons. So they might take over, manually disengage, drive the vehicle up, and then restart the automation. And so we refer to that person as the driver. There's a separate operator up front in the passenger seat that is using the tablet to kind of initiate the ADS and kind of select routes and assist the driver. Just for nomenclature, we use driver in this experiment. So here's our apparatus. This is a level 3-4 automated vehicle that was outfitted by Prone. It's a small kind of GEM vehicle that was outfitted with a ADS system. And so it has 3 radar units, 2 kind of above the wheels and 1 up front, and then 2 LiDAR units on the front, 1 on the back. It uses a sensor fusion between those radar and LiDAR units to identify obstacles in its path. And then it has 2 camera units used exclusively for data collection at this point. It's not used in the ADS tech stack. One is a forward view, and one is a view of the driver that we'll be using in this research. And so this and this is a very much GPS based automation. So it's following kind of digital breadcrumbs that we've created from this route and kind of recreating that path. We set speed limits. We hand annotate the routes where intersection control is and where potential conflicts are. And then the vehicle kind of recreates that route that we've trained for it. So I'll kind of show you a little bit of what some of the data looks like from the standpoint of the visualizer. So this kind of shows what one of our main routes that we first programmed for the we call it the Badger. It's the AV that we use in these experiments, and so you can see, each cycle is that kind of 1/10 of a second where we're collecting data and course correcting for heading speed. And so just briefly kind of looking at what the visualizer looks like, and quickly play this video. And so you'll kind of see as the path goes through, you'll come into an intersection, you'll see a lot orange. That's kind of the LiDAR radar fusion, identifying potential conflicts, and then and you can kind of see where those conflict zones are that we're again hand annotating where the vehicle is looking for potential conflicts as we drive through this course. And so that gives you a little bit of sense of the vehicle we're using. Again, I don't want to get into too many specifics of this particular vehicle. This is the vehicle we use, and obviously there's idiosyncrasies about it that kind of were tailored for the research, but certainly you could, one could use a different vehicle for this type of research. And so looking at the 2 kind of different experimental setups, we had kind of 2 different routes designed for the rider trust, and 2 different routes designed for the driver disengagements. And so first, we looked at a parking lot, a very simple parking lot study, and then secondly, we drove that route that you saw immediately before, that's on neighborhood streets going through several intersections, including some all-way and side street stops. And so we did this back in March 2023, and then a separate study looking at these 2 routes. So slightly to the left here, in the neighborhood, where we basically route 1 covered this track, and then route 2 did the same track but did an extra looped around this twice, and we really just did that to differentiate the route during one of the runs. We had 4 drivers in that experimental design. Unfortunately, we were limited by university rules that we didn't know getting into the project, that we could not use the university vehicles for anyone outside the university. So that's a university fleet policy, and the vehicle is currently in the university fleet. And so this just gives you a quick flavor of some of the data that we get. So this is the overhead camera, so we can see general head position and hand position on the steering wheel, which is very helpful for our driver disengagements, as well as what's going on up front. Again, these are not used in the ADS stack, but are simply for data collection purposes. Some of the data preparation, so use a Python script to kind of go through the output data. Upfront's very helpful in that they allow access to their output log, and we're able to parse that into various component data sets for our purposes. And here's a quick look at kind of what some of that data looks like. So we got cycle mode, timestamp for each of those cycles, lat long, the current speed and heading, as well as a desired speed and heading, and the detection. So that would be the detected width of objects. Those objects are not classified. We don't have vision-based classification on here. It is just the width and kind of distance to that object from the vehicle. And so for methods, for the first one, for rider trust, as far as the data preparation goes, we took four measures over the course of a few weeks, to both 2 weeks before riding, immediately before riding, understanding their expectations. Immediately after riding, we got general observations, and then 1 week after riding, we again followed up with a questionnaire. So a several item questionnaire looking at comfort, looking at expectation of driver ability, AV ability, familiarity with that technology. And so that's a repeated measure, so we could kind of understand how that trust evolved over time. Just really quickly, I want to kind of give you a sense of what the parking lot run looked like. So in this case, we just went around the parking lot. This is half of the parking lot run. In these cases, we kind of had a simulated pedestrian come out. This is one of our employees. And so in this case, you see that it successfully yields to that pedestrian, but then he kind of comes out a little bit, and it performs what's called a bump around. So any object that's kind of to the right of it, this was specifically tailored to parked vehicles, but it doesn't discern between pedestrians and parked vehicles. It'll just kind of bump around, kind of shift transversely to the left to get around that object. It does occur very close, so it doesn't really give a whole lateral distance to that pedestrian. And then just a quick series. So we did 3 runs for this rider trust study. This is one of those intersections where it's a side street. This is 25-mile-an-hour roadway. You can see that it successfully navigates and yields to that vehicle before initiating its turn onto the main street. This is run 2. You can see again, it comes up, stops, doesn't have that conflict. There's a potential conflict on the other side, but they're yielding to us, and then it successfully navigates that. And then on run 3, there's a garbage truck parked to the south of us, to the left of the screen over here. Another vehicle comes around, and it does not observe that vehicle, and we did have to disengage here to stop, let those vehicles go through. And so that's just a quick flavor of kind of, we did these repeated trials with the riders for them to kind of gauge, special conditions. We can't control the environment around us, but we obviously will disengage if the vehicle is not operating appropriately. And so we did ask folks, again, 2 weeks before, right before, and then 1 week after, about their kind of confidence in the AV's ability. And you see, generally, we would be saying, this is only 2 riders. We had 3 riders initially. One of them had inconsistent results that we weren't able to track their data. And so, albeit a very limited sample size, we're able to still determine that there is large deviations between these folks. And so we might expect that across many more riders. But in this case, we did see over time, certainly rider 1's confidence decreasing, and for the most part, rider 2's confidence decreasing, and rider 1's kind of shifting in different ways. These are some observations directly after the run, so you can note that for this is rider 2, so they were scared the way that the pedestrian or the AV was interacting with the pedestrians and weren't comfortable with how close it got to them. As I mentioned, that kind of bump around, it assumes that that's a static object and kind of laterally shifts, but not that much. And so it doesn't really have a yield. Those are all, parameters we can control more, but in this case, it was under a controlled environment. And then certainly that oncoming traffic on that run 3, it successfully navigated that intersection twice, especially the first time with potential conflicts, but didn't successfully navigate it the third time. And that was an observation made by one of the riders. So we just see that these, as one might expect, we had kind of more elevated expectations of the AV, and then upon the AV failing in certain aspects, those expectations generally reduced or stayed the same. And then we also wanted to ask about perceived differences between operators. So this is kind of that crossover between how operators might experience or might handle these circumstances differently. So we did see, again, differences between folks. So generally, rider 1 felt like those differences were not apparent after riding, but thought they might be apparent before riding. And then rider 2 still thought there were differences between the two operators. The second method for driver disengagements, so we defined 2 different types of disengagements, a timeout and a potential conflict. Timeout is really when the ADS doesn't successfully go through an intersection. It perceives that there's a conflict, but there's not, and it just will not go. Whereas potential conflict is defined as, the driver perceives that there's a potential conflict, whether or not there is one. So we didn't disambiguate between real conflicts and perceived ones. And so this is just a quick example of, the operator kind of taking over at the beginning of the video and then, disengaging and driving around that conflict. In that case, it was, folks working on their car in the roadway. And so for the results of the driver disengagement, we see certainly their disengagements per mile were generally similar or reduced over runs. So as I mentioned, in this case, the drivers took 3 runs, and we had a little bit of added complexity with that extra loop to try to differentiate it for folks. But in general, disengagements per mile were similar or reduced, except for operator 3, which in their last one went up slightly. And then those number of disengagements and the proportion of those timeout to perceived conflict were definitely varied across drivers. So we definitely saw differences across drivers. And this has implications for when we're running in-field tests. The operator does affect whether how long they wait at intersections for timeout type errors, and their perception of dangers, and when they actively disengage before a potential conflict. And so just quickly, we present this in the report that we have kind of these successive series on the left, just kind of denoting when a driver disengagement happens, kind of the hand position before and after. And there has been some research that has shown that this is one aspect of driver comfort, kind of where their hand position is, mainly referring to ADAS or ADAS systems, level 1 and 2. And then the run map just kind of shows, each one, and there's a dot for basically each tenth of a second, and then over time you can kind of see where those disengagements happened and what type they were. And we have that for all the runs that we have access to. So there were some limitations. I just kind of want to mention them briefly, that because we were limited to UW employees, we have a limited sample size. And although we currently envision this as a concurrent study so we can understand how riders perceived these drivers at the same time, we had to separate those two. As I mentioned, those we had 3 dates for the drivers and 1 separate date for the riders. And then, unfortunately, the great thing about the real world testing is that we have real potential conflicts. There's a lot of validity that could add with kind of that real world experience. But that some of that natural variation in traffic conditions, folks working on their car during certain runs and not, lighting, GPS quality, etc., contribute to kind of some uncontrollable variance within the vehicle itself. Ideally, we would have a very similar test condition for all runs for all drivers, and that wasn't the case. In future studies, we could certainly try to increase the number of samples for each driver, as well as the number of drivers. And I guess this is really just kind of a building block of some of our initial exploratory research that we understand that there are significant differences between riders and drivers, um, and and within them over time. And so we just kind of want to make that clear that, and that has implications from kind of when we study folks. And again, all these folks were somewhat familiar with AVs to begin with. They all the drivers had driver training beforehand, but they had not been exposed to this course before, so this is relatively new for them. And as they drove, they became more comfortable with the course and had less disengagements. And then certainly some future research that we looking for, obviously expanding to more drivers and riders, more scenarios, but then as well, potentially taking a crossover study to look at how we could move some of these routes into the simulator to compare the results across different modes. And so that's definitely something we want to try to do, as well as homogenize the runs so that they're a little bit more consistent across drivers, and we can isolate some of the effects of just the driver and rider behavior. So with that, I think we're all finished up. Or if there are any questions, I'm happy to take them. Otherwise, my contact information is included there. I'm happy to take follow-up questions about this research.
Thank you very much, Andrew. I'll invite any of the attendees to unmute and ask a question if they'd like. So in the meantime, I'll ask you a little bit. You said that all the participants had familiarity with AVs. Do you recall what kind of familiarity, how you measured that?
Yeah, so we did include that as a survey question on the riders. Obviously, the drivers had a 2.5 hour training where they kind of learned about the vehicle and did some supervised test runs. But again, so for them, that was obvious that they knew. But for the riders, yeah, we included one survey item specifically related to their level of familiarity.
Did you see a lot of variation in that? What I'm wondering about is if familiarity affected their before, during, and after scores. Like if they were familiar, was it more even? If they weren't familiar, did it change a lot? I know the sample size is really small.
Right.
I'm just sort of, it's a something I wonder about.
Yeah, I definitely think that would affect. I mean, certainly their confidence having all of them kind of purported to be knowledgeable or experts in the field. So I would say that they had an expectation that it would work better than probably it did. So that wouldn't necessarily be the case for the average person who doesn't know too much about automated vehicles.
Yeah.
So that's definitely a consideration. Again, if we can expand this in future studies to get writers, who don't have that background, I think that will go a long way to understand. There's been plenty of other studies that kind of show how some perceptions change depending upon whether or not you have that bias for or against. But we really couldn't answer that with this kind of limited writer study, unfortunately.
Okay. So we have a couple questions in the chat, and I'll just read them out loud.
Sure.
So hang on, I'm gonna close the participants so I can see all of them. So Vincent wrote, really amazing research. Thank you so much for sharing. In this early research, was there any emergency vehicle interaction? And if so, was disengagement needed?
Not during these runs. We did not have, there are hospitals nearby, but there's no emergency vehicles. Yeah, lights and sirens during this time. Certainly, we don't expect this vehicle to perceive that. So yeah, we would have to disengage and pull over at a time if that were to happen.
Okay, thank you. And then Jason wrote, what type of experiments, tests would show if automation is and how much it is improving safety? That's a big question.
Right. Yeah, that's certainly not I think our little piece of the puzzle here was to what extent do, knowing that we're testing a lot of automated vehicles in a lot of different contexts to kind of determine that, and obviously over, thousands of miles to more accurately determine its safety under a variety of contexts. Um, this is a little piece of the puzzle that says that it does matter who's behind the wheel, potentially understanding when those runs get terminated, um, to the degree that folks can perceive that safety differently. I think that's been kind of shown in some other research, certainly on these new technologies. But we just kind of want to prove that in kind of our context, that
Mm.
there are differences between the operators as far as what data we're collecting and what conditions we're exposing the vehicle to.
Right. Right, I imagine your presentation focused on trust, and there's a difference between performance-based or performance metrics-based safety that we can get from like the vehicles themselves and things like that, and then the perceptions of that safety.
Mhm.
And people sometimes under and over trust technology, and so that's a really big question, Jason. You're welcome to unmute yourself and ask follow-up questions or give a perspective if you'd like. I hope I've represented your question well.
I have a question, Andrew. How's the time of arrival baked into this? By that, I mean the behavior could be less or more assertive, and that could affect the user and trust of it. How was this baked into the study?
Do you mean on the driver's side? I'm
Correct.
assuming. Okay.
Yes.
Yeah, that's a great point. So we had originally envisioned some kind of more artificial uh, uh, interventions. So we would have, a dedicated place where we would have a pedestrian walk out, and then kind of have those consistent incursions across all drivers. Unfortunately, for budgetary and time reasons, we weren't able to make that happen. So we just kind of ran with the context, knowing that it was all the same streets under the same, you know, relatively the same time period, as far as time of day. But there were certainly new conditions for certain drivers that other drivers didn't experience. So, the sample size of 3 is really not sufficient at this point to say, that, to have some stationarity of across all runs. But this is that initial exploratory analysis to understand that, considering that these are similar contexts, certainly on the timeout, I'll just briefly jump back here. So potentially on the potential conflict, because those can be wildly different for different contexts. On the timeout disengagements, there was definitely a huge variation across those, and those are the ones that are relatively similar across all drivers. And so just to quickly hit that, so on these timeouts, some folks were very patient with the ADS, willing to wait there, for like up to a minute at an intersection until the vehicle safely proceeded through the intersection, whereas other ones, a few seconds. And so we definitely saw, from a patient's perspective, these drivers were given the same directions, and so we certainly saw a huge difference there. The conflicts, unfortunately, there is kind of uncontrollable variance there that we couldn't control for. So we didn't want to go into too many specifics as far as if whether that those were perceived or real conflicts, but to the extent that we can see that there's definitely a proportional difference across different drivers in these similar contexts. Does that make sense? Hopefully that.
Yeah, that does. Thanks a lot. And I'm wondering, were these incident and trust of the drivers categorized based on the ODD elements and what they've encountered?
Um, no, I mean, for the most part, it was just kind of, we documented each disengagement, and then we kind of quantify. There's been some. It kind of depends on study of how they classify. Certainly with some of those, um, state-based forms of kind of what type of disengagement was, we kind of generalized it to either one, of associated with a potential, near-term conflict, or for another reason. And in this case, all the other reasons were the timeouts, but not associated specifically with ODD.
Fair enough. Thanks a lot.
Thank you, Omid. Does anyone else have a question or a comment? You're welcome to simply unmute yourself if able. If not, please type in chat. Okay, I don't see anybody typing. Andrew, I want to thank you very much for your presentation. I am sorry that Dr. Payne Lee's presentation had to be rescheduled. I believe it is in August. We will be sending an announcement out for that. So please look for that, because that presentation is related to this one. And Andrew, again, thank you very much.
Yeah, thanks for all the great questions.